Okay, back we go. See which mic thing I'm on. Wrong one. There we go. Okay. Get as many hours in as I can. I don't have any video games I want to play. Because they don't exist, so. I could sit, lay down, and consume some stories, but I'd rather do that in the morning when I know I don't have shit for the day. So, I think Seth's coming over, probably on vibe code or something. Learn to integrate AI in games, if even possible. Might be totally useless, but we'll see. I'm still getting my shit done, so it's okay. Yep. Yeah, we learned that making an identifier static or const expression for global things. The function that's in globals, well, let's see. It limits it so that other files can't access it, or at least, yeah. Yeah. It's like, my fan's too hot. Okay. Alright, so I'm gonna have one program, a function here, or a file, Jesus. I'm gonna call a function that's not static, which will call another function that is static. Okay. Need input and output, so we'll start with that. We're gonna call it stuff. What are we gonna call it? Linkage test. If not defined, linkage test. Define linkage test. Cool. Here we'll have namespace linkage. It'll have one function called do things, and it'll take that one. It'll take two integers, and then there'll be another function called print things. Hmm. Hmm. And we don't need that. Oops. Cool. Oh, we also don't need this guy. Okay. Then we need an implementation file. Take the same stuff, or we can say the memory link namespace linkage void do things int value 1 int thing 1 int thing 2. And what do things will do is call print things oh wait, what the fuck? Is call print things thing 1 thing 2, and inside here is also void print things int thing 1 int thing 2, and it will well, what are we actually gonna do? What do we want this function to do? I want it to output shit? I guess so. I can do that. So, alright, this will include IOStream too then. Alright, so we don't need it in here. Well, we might, because we might need it later. No, but it'll be included transitively, so. Okay. So what this is gonna do, this is, need help, helper function, need helper function. Oh, excuse me. Now we're gonna include linkage. Oops. We've included it now. And print things is a static void. So we can call this guy. So these 4 declarations will be included upon being included. And then we can call do things. We can't call print things. Let's see how it happens. So we'll say int, or we'll just say, I want a function to get stuff from the user? Could. I guess we can do that. just say int get int. Oops. Then we're gonna do character output to get the value. The value is just an integer. It's easy peasy. Cool. So we're gonna say, oops. Must still be tired of messing up. Cool. And we'll say index is linkage. Oh, hold on. Oh, didn't forward declare, that's why. Cool. So we need two integer variables, which we'll get with this function. The function is not static, so it is externally linked. Or it has external linkage, so it's exposed basically to other files, or it's usable within other files. Cool. And then we'll do linkage do things, and we'll pass it x and y. And we'll print. So we'll do 4 and 2. And that's this thing like that. Why is there a space after the fucking period? Who knows? Oh, because it's that. That's why. Boop. We go now. 2, 1, 4. Thing 2 is 2. Cool. But if we go here and we do linkage, put a print things x, y. We have static voids here. It's declared not defined because it can't find them. So it generates a compiler error because we're trying to use a static function from a different file. Okay. Oh, because otherwise, I mean, it has a declaration, but it's not defined because the linker can't connect the identifier from one translation unit to the definition. So this translation unit, that's the main file, that's CPP, main CPP, has the forward declaration because .h is included. But the static identifier is not exposed to the linker, so the linker can't see the definition. Oh, so for inline stuff, the linker can remove the extra stuff. Gotcha. Okay. Soon. This chapter and then one more and then we're there. Hmm. Mm-hmm. Makes sense. So the forward declaration makes the compiler happy. And because of the global linkage, the linker does the rest. It connects the call. Linker doesn't give a shit about the forward declaration. The compiler does. That way it knows what's going on. Yep. Yep. Mm-hmm. Yep. Alright. Tired of these now. Yeah, I'll cook spaghetti later tonight. Cook some chicken. I have pasta. Excuse me. I have tomatoes. Put them in a pan with some oil, garlic, spices. Make some nice sauce. Oh, that'll be good. That'll be real good. Oh, and I'll do like shredded little bits of chicken instead of one big piece. Oh, that'll be nice. Alright. So we're in main. We need a function that prints 5. So we'll do print 5. Okay. And we'll have a declaration here. We'll just say void print 5, and it doesn't do anything, doesn't have anything. And then we'll also have a C++ file that is print 5. We'll just call it linkage, if not defined, linkage, define linkage, and if And we'll say void print 5. Oh, we don't actually need header. Oh wait, it's a CPP file. Whoops, that's it. Alright, so we don't need that at all. It was totally wrong. So I need IOStream because print 5 is going to be doing the printing. Void print 5. Cool. Okay, so we can print 5. Because the linker will normally go through all the files and combine them and link what's going on. So we're calling print 5 here. So if we had this, print 5 doesn't do anything, but if we didn't have this at all, then the linking error because it doesn't exist. But if we do static void print 5, internal linkage has been removed. What if we put it in a namespace? Well, actually, might have to include that. No, actually, we're only including the header file for that, so we can just do namespace stuff. What if I do this and then do this? Okay, that's great. Dang, that's unfortunate. All right. Do that. Namespace stuff. You can say, oh, what if we said static void print 5? So if we remove static, we're not doing anything yet. And if we say stuff print, what is it called? Oh, we don't know the namespace. We would have to include that. So the namespace doesn't exist. So we can't do it with a namespace. Well, we can print 5. Then if we do static void print 5, doesn't work for various reasons. Okay. Most I'll get out of it for now. Oh, what if I had it'd probably say the same thing if I had this. If we had and we'll just say print 5 const well, hold on. So we actually don't want that. We need input and output by the input and output stream types. iStream and OStream and get 5, we'll say. And we're gonna say const int get 5. For declaration, we'll say constant get 5. Return about it's a const expression. It'll do that. if we said static, oh, hold on. If we say constant get 5, constant get 5, it's fine. If I remove this, it doesn't know that it exists. If we say const expression get 5, const expression get 5, there's a linking error. Because it doesn't know get 5 because he's static. It can only be used in its file. Unless... But didn't we have const expression functions that were doing that? I think I was accessing them via namespace though. No, because maybe. Alright, so we learned about external linkage. Now I'll learn about internal linkage. Or internal linkage. Now we'll learn about external linkage to see how this shit works. Bro. Oh. Why are my hands clammy? I have because I've been grabbing seeds, that's why. What did const variables do? So maybe not const function? Okay. So find out here variable for declarations. I need some music. I kind of want to go a little hardcore here. can connect this function call to the actual function's definition, so that the function indeed exists. These functions need definitions. Makes sense. May be actually. It just depends on those rules. Well, I mean, you would expect that to be the case. actually be. You can't actually give a. It seems like you can't actually give a const expression variable external linkage. You can only do internal linkage, but then get access to it through a namespace, maybe. Because it sounds like linkage still only matters if we're talking about stuff that's in global scope. Okay. versus oh, well, wouldn't need that if it was like that. We would need it if it's, let's see. Oh, actually, yes, we would need extern int here if we were just defining it somewhere else. If we just had extern int x, that, and we're outputting x, like that. This guy's needed because if we don't, let's see what happens. Linking issue because he's being defined. It's thinking that this guy is defined as an uninitialized variable instead of knowing that it's a for declaration for this guy. So we can't access this guy. So the linking issue is that this guy's defined and this one's here. So if we do that, we can use it. But if we put this guy back, can't link him because it sees that there's an X here. X is being used here. And he's already defined, so we have a multiple definition of the same identifier in multiple, or in the same, in this program. Bro, this guy needs to be. Wish I could move that down. I don't know why that keeps. Oh, I'm just gonna change the name. Cool. It's better. Excuse me. Cool. Don't use extern on a non-const global variable with an initializer. It's the same shit because it's already extern. It's already extern. Now it's explicitly. Would we have an issue? Oops. Need input and output. Zero. 5. We don't need that here, so it's fine either way. This has an issue because it's thinking that this is a separate variable that is being defined as uninitialized, and then it's being x is being this identifier is being defined again. Two identifiers are breaking the one definition rule. So we have to say extern here in the for declaration to tell it this is a for declaration. Don't put extern here because I don't know. Apparently the compiler little bitch at you maybe. Because it's already by default external. Yeah. It's explicit. It's applied to a non-const variable. We want a for declaration. Ah, it makes sense. Yeah. So now we're adding it to a non-const variable, but it's not a for declaration because it's being defined, makes it a definition instead. Eventually, it's applied to a non-const variable. Yeah, makes sense. Yeah, because it's combining a definition and a declaration basically. The initializer doesn't require extern because we use extern. Well, yeah, because it's already extern by default, and we use extern specifically to say that this is a for declaration. But because it has an initializer, by definition, it's not a for Well, yeah, it's not a for declaration because it has an because it has an initializer. It's so hard to say these words quickly. Okay, makes sense. So don't add ambiguity. If it already has an initializer, it's already a definition. If we add extern to it to make it, it will look like a for declaration that has an initializer, which is weird. VS Code is Visual Studio is cool with it, but maybe others aren't. Maybe. Nice, cool. I get to show these. Check these. So for const definitions, because they already have internal linkage, and then for the for declarations of non-const variables, yes, do not use it for non-const global variable definitions because they're already external. It adds ambiguity, and the compiler might bitch. So the first one, it's a for declaration of a global variable, and then a for declaration of constant as well. And then we don't do that for const expression because that'll give you a compiler error. Because const expressions have to have initializers, so we can't forward declare them. But if we do them const, then maybe they'll be compile time. It's as close as we can get. If it's used in a const expression, then it'll be at compile time. We have int x, so we could have an external undefined global variable or an external initialized global variable. So we have a non-initialized, then we have the initialized, and then we have external const. Yeah, we have an external constant, which is initialized, and then we have an external const expression. Again, we can't do it. Well, hold on. external const express. That part's not allowed, but we can do it if it's initialized, but we can't do the full. So then we wouldn't do that because we'd have the for declared anyways. Yeah, because we have extern with an initializer, so sure, this is internal, but now it's external. So we could do this, we just can't do the for declaration. Which means we can't fucking use it then if we don't have a for declaration. Right? Oh, whoops, where's const express? Yeah, we wouldn't do that. External const expression. It's useless because we need a for declaration to even access it in a different file because it has internal linkage. But because it has because const expressions require initializers whenever they're used, you can't for declare a const expression in. That time? Not yet. Okay. Okay. Difference between a variable scope, duration, and linkage, and then other stuff. Okay, so we'll see. So a variable scope tells you where the variable is usable. So where it's known. If we're within a block of code and there's a local variable in there, you can use that local variable in there. If we go outside that block, so closer to global scope, then can't use that anymore. But if we go further into more scope by going further deeper into other blocks, we can still use variables that are outside of that scope. So variable scope defines where the identifier / variable can be used. Duration includes the rules that define where the variable, where basically defines duration is a term that describes the rules. Duration includes the rules that describe and govern the lifetime of variables. So duration of one type of variable is this, the duration of this type of variable is this. So for the duration of a local variable, the duration states that local variables, that local variables are created upon definition and destroyed at the end of their scope, which is usually the ending curly brace of wherever they are. Well, yeah, if it's a local variable, it is the ending curly brace. Unless maybe you allocated memory dynamically for it and then freed it for, maybe that's the case, but I think you would do that after it's technically destroyed because you can't free memory without destroying it. Maybe that's true. I figure you would probably destroy something, remove something from memory, and then free the memory. I don't know though. So we'll say for local variables is that. For global variables, the duration states that the variable is again created upon definition, which is wherever it is in global scope, and it is destroyed upon the program's conclusion, upon the program's completion. So, let's see. It seems like maybe global variables are actually created upon the program start because global variables by definition are in global scope, but maybe there's an order to things. So maybe it runs down and says, okay, there's this namespace that has this stuff in there, and then there's another namespace in it, and then there's this global variable in it. At that point, that's where that variable is defined and is alive until the end of the program. Lifetime would be the time, the actual duration, or the length of time that it's alive. And duration says that time is from definition to destruction, which for local variables is from definition to the next closing curly brackets, or the end of its scope. Say it's only alive within its scope, definition to end scope, and then for global variables, that's from definition until the end of the program. Linkage describes whether two references to the same identifier are actually, or two uses of the same identifier in different files are referring to the same object. For local variables, hold on. For local variables, there is no linkage. A variable within one function is, by definition, different and in a different place of memory than another function. Even if they're talking about the same stuff, they themselves are in different spots. Even if their values are the same or they're looking at the same reference, they're still stored in two separate buckets in this large array of memory that we have. For global variables, there's internal and external linkage. Linkage, again, describes whether or not whether two uses of an identifier, or whether the use of an identifier in two separate files refers to the same object. So for global variables, it depends. So by default, non-const variables have external linkage. So I could put it in a CPP file, and they go to my main CPP file, and then as long as I have a forward declaration in there to see the variable so that the compiler's happy and we don't just use it out of nowhere, then we can use, without having to do an extern keyword, an extern qualifier, or I guess it's not, maybe it's not a qualifier, but I'm gonna say it's a qualifier. An extern, I'll say keyword because that's more ambiguous because I'm not sure just yet. So without using the extern keyword, non-const variables are already externally have external linkage. If we make them const or const expression, then they have internal linkage. We can make those extern by making them extern const. And we don't use extern const expression because, again, for us to use a variable in one file that's stored in one file and use it in another, for us to use a variable stored in one file in another file, we have to put a for declaration of it in the using file. We can't put a for declaration to a const expression because it requires an initializer. The for declaration does not have an initializer. So this has been initialized upon definition. So instead, we just say extern const, turn the default const variable's internal linkage to external linkage. What kind of scope, duration, and linkage do global variables have? Again, for scope, they're in scope from. Let's see. Duration says that they are created upon definition and destroyed upon the program's completion. They're in scope through the entire program, everywhere everything can use them, depending on. Well, let's see. They're in scope. Hold on. I think they're in scope everywhere. Everywhere can use a global variable. So we put X in some file. As long as we have a for declaration to it in another file, then we can use it wherever it is. Unless we make it. We can also use static to make it internal linkage. So we could say an int, just a regular int, a non-const variable. We can give it static, make it internal linkage. We can do static, const, or const expression. And then we can take const and then make it extern in order to make it external linkage. It's non-const, already external, and const expression can't do it. At least not with a for declaration, so not in another file. Linkage of global variables. So in the scope of global variables, it's in scope everywhere. So if I have a variable that's global, and I can use it in any functions in the program, provided that I have a for declaration to that variable here, so that I can use this definition. And then for the linkage, it can be internal or external. It depends on what the variable is. Is it non-const or is it const? Is it extern const? And I think that covers everything. Is it static? So there'd be static non-const, or just a non-const, or a const, or an extern const. And or an extern non-const as a for declaration, or an extern const as a for declaration, or just a declaration or just or no extern, nothing else, just the variable itself with no initializer as defining it as an uninitialized. For declare it, we would still need the same extern. Extern int x, no initializer. It's a for declaration to an uninitialized x. Doesn't know it's uninitialized yet, but if we go in the definition, then we just say int x. We don't put extern there because then it thinks that is again a for declaration. You get a linking error. I think that's that. Let's see if I'm missing anything. So scope determines where it's accessible. Duration determines when it's created or destroyed. Linkage determines whether it can be exported to another file or not. Global variables have global scope, which means they can be accessed from the point of declaration. And if in any given file, they can be used from the point that they're declared in the file. That way, the compiler knows that they exist. The end of the file which they're declared. Okay. Not necessarily program's completion, but the file's completion. They have, well, the scope. So, I mean, they have scope from the entire. I mean, well, I was correct actually. I was thinking that I was looking at duration. So scope, yes, they're in scope from the entirety of the file. So the second that the file's aware of it, so like if we say x here, this global variable x, and then we use it somewhere, it's in scope the entire time. It's not going out of scope in that file. It has static duration. Static duration means that it will last until, or from its creation till the end of the program. So they're not destroyed otherwise. Then they can have internal or external, the static or external keywords. Yep. Why non-const global variables are evil. Okay. Non-const variable. Okay. So far we could have the uninitialized guy, or we can have just the regular non-const, or the uninitialized non-const, or the non-const. Yeah, I guess because you could use them and keep updating them. Then they're all in scope the whole time, and you're using up memory, bro. Especially if we're talking about global variables. We're not necessarily talking about global integral variables. So just like, oh, it's a little boolean. It's only 2 bytes. Oh, he's an int, little cutie. He's only 4 bytes. No, bro. It'd be a big ass thing. Mm. Well, instead of having to say like passing it using arguments to initialize and create the parameters, we just use the functions to operate on already existing variables that whose lifetime is until the end of the program and duration, same shit. Yeah, true. Yeah. Yeah, because it doesn't even have a type anyway, so of course it doesn't. It sets the one, and then we're gonna do something, and then it sets it to two, and then the programmer expects it to be one, because whatever, you didn't know that that function changed it to two, so now you have to check every fucking function to see if it's changing it. Oh, that's a pain. Jesus. Launching nuclear missiles. Yeah, you'd have to know that. If someone else made that function, you don't know. You thought you were the only one setting the variable, but instead, like you literally just set it to be one, and then if it's one, no threat detected. Okay, cool. It shouldn't be threat detected. I mean, it's easy to know that do something has to be the thing that's changing it here, but if do something calls different functions, and then one of those is actually the culprit that changes it because it's non-const, you're fucked. GG's. But if it was only passing values, then, well, the global variable can't be changed, so the constant's okay. You could have a local variable and set it to be one of those two. So like when threat's detected, and set it to equal that or something. But and you could go through your little function and know whether or not it's one or not. Yeah, good job, writer. Yep. Sounds like these anti non-const global variable regime lobbyists. You guys do not like non-const global variables at all. Yep. Yep. Woo, thank God for no linkage. Yep. Exactly as I said earlier. It's non-const, and you have a bunch of functions that are using it, maybe changing it, maybe you accidentally changed it, now you don't expect it to be changing, and everything looks right, maybe. Maybe it's looking at it, but then you accidentally did whatever. If it equals something, but instead you did if plus equals, and now game mode just fucking doubled. Or, well, no, because maybe you added shit to it. So instead of saying if game mode is 4, you're saying if game mode plus equals 4, which means if game mode plus equals 4, well, you know that it's going to be true, and it's going to evaluate that guy. Well, actually, maybe it's. Well, yeah, because plus equals means that it's going to be assigning it the value of it plus 4. So, yeah, you know that's going to be true because it plus 4, unless it's really low negative, unless it's negative 4 or below, it'll be true then. Likely to be true. Yep. Gotta go through all the functions that could possibly be changing it and using it to find out. Yeah, also true. If it's non-const, then something in another file could be changing it. Oh, good God. Yep. Oof. Oh my God. Oh my fuck. That is terrible. bug tickling my ball? What's happening? Alright, we're good. Yep. 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 Yeah, if it's just an extra little thing like, oh, the date is global. Everything can access date. Okay, cool. Maybe don't make it const because the date has to change. Or just make the things that use the date track the date, and then make things that talk to them pass the date. Maybe not. Maybe you have a phone. Maybe make the character store the date, and then I don't know. Hmm. Don't use global variables for important shit. Noted. Okay. All right, time to go. That's nice. Almost 4 hours of coding. All right, do more tomorrow.